All right, and welcome to the next day of linear equations. We're going to be looking at some word problems. Word problems shouldn't scare you. These are not tricky type, confusing word problems. I'm trying to use real everyday application type problems. Hopefully you don't speed, but if you do, there are some different ways that people calculate speeding fines. So that's what we're going to be looking at today. Within linear equations, one of the things that's talked about common is independent and dependent variables. And it's important to just understand what they are. The easiest way to think about independent and dependent variables are which one depends on the other one. So in this case, what you should know is that what depends? Well, the fine depends on your speed. And you can think about it that way. So that's how you figure out what your independent and dependent variables, which one depends on the other. In this case, the fine depends on how fast you are going. So here, anything over 70 miles an hour is considered speeding. Speeding fine is a flat fee of $40 plus $10 for every mile per hour. It's over the speed limit. So our rule for f of m, and if you think about the y equals mx plus b, and I'll put this over here, mx plus b. This is the constant. This is how it changes, or this is the starting point, and this is the rate of change. So if we think about that in terms of this problem, we're starting at 40, which is our starting point, and our rate of change is 10. Now, what's also important here is not just to get the equation, but to understand what the x stands for, because in this case, x is not the speed of the car. If you're going 10 miles an hour, you're not going to do 10 times 10 plus 40 and be charged $140 for going 10 miles an hour. But x in this case is miles per hour over the speed limit. And anytime you do these problems, it's kind of important to make sure you understand what that indicates. So that's what we're looking for in this problem. So if you were traveling at 78 miles per hour, you're not going to plug 78 in for x. What you're going to do is figure out what happens when you're going 8 miles an hour over the speed limit. So 10 times 8 plus 40, which is 80 plus 40, which is $120 fine if you get caught speeding for 8 miles an hour over the speed limit. Now, you could also use this equation backwards. Let's say you were $200. Well, what speed, how fast were we going over the speed limit if we had a $200 fine? So I can subtract 40, sorry, and x is equal to 16. However, it doesn't answer the question, does it? We are 16 miles per hour over the speed limit, so it was 86 miles per hour. So again, it's very important not just plug in numbers, but to actually know what your numbers stand for when you plug in the equation. If we look here, two other terms, domain and range. So the domain, these are your, I would say, x values, or your independent values. And the range is your y values, or your dependent values. And the idea behind this, your independent and dependent values, is our independent values is the speed, the dependent is the fine. So what are some reasonable speeds for the fine? Well, it has to be going over 70 miles an hour. So anything between, and I'll use this notation, I would say from 70, if we use the open parentheses, from 70 all the way up to, I don't know, reasonable speed, maybe 120 miles per hour. What are the dependent variables? Well, at 70 miles an hour, you're going to get 0. So there is a possibility of getting, no ticket if you're going the speed limit. If you're going 50 miles an hour over the speed limit, if we go back to the equation on the previous page, if you plug in 50 miles an hour over the speed limit here, which is a crazy fast speed, you're going to be $540 ticket. So these answers can vary. They don't have to be I mean, if you wanted to put 70 to say 150 miles an hour, if you think somebody can really go 150 miles an hour, you can then change this value. But your domain and range, your domain is the X, the range is the Y values. So I hope that helps. Good luck. Thank you.